Alright guys, next part of Trig. We're going to use our calculators. First thing you do, find the mode. Right? Find your calculator, whatever you have. There will be something that says mode. You want to click mode and you want to make sure you're highlighting degree. Alright? There'll be choices of degree, radians, and gradians. You just want to use degrees. It's all we're working in right now. Okay? So once you find your mode, put in degree mode. Here's how we can check together. Now the order in which you do it depends on the calculator you have. Let's put the sine of 90. See, for me, I hit sine 90, enter. Should equal 1. So my keystroke is sine 90, enter. And it should be 1. That's a great way to check it. Okay, that is a great way to check it. Let's do some random ones together, see if we get the same things, okay? Let's try the cosine of 84, the tangent of 23. Okay? So once you're in your calculator, do the cosine of 84 and the sine, and the tangent of 23. So for me, cosine of 84, 0.105, or we can do 3 decimal places is good. Let's do the tangent of 23, 0.424. If your calculator is not giving you those answers, you have to find your owner's manual, whatever you have to for your particular calculator, that you can go to mode and then go into degrees. Okay, mode and then go into degrees. We're going to take now our ability to find the sine, cosine, and tangent of angles and then apply it to our trig ratios. We'll call this theta, we'll call this x, and we'll call this 19. Okay? The first thing you have to do when solving this, all right, is which trig ratio would I use? We have sine, cosine, and tangent. Here's my theta. What is x in relation to theta? Correct. Opposite. What is 19 in relation to theta? Let's see if we can get that glare off a little bit. 19 is the hypotenuse. So, which trig ratio is opposite and hypotenuse? Yep, sine. So the sine of theta is x over 19. Whoa, 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 stop the presses. Stop the presses. We have 2 variables here. We can't solve in 2 variables. We're not doing systems. What would we need? Well, you can do either one, but what we're going to do is we're not going to work inverses yet. So let's just pick a number. Pick a number for me. It doesn't matter. Emily, pick a number. No, you don't got one? Max, how about you pick a number, Max? Nobody's answering. Oh, you're not listening either. Good. Let's just take this as 40 degrees. So what this really would be is instead of theta, it's just going to be the sine of 40. So remember, theta is a variable. So if I have the angle measure, I would take the trig function of that angle measure. Well, let's look. How would you solve this? How would I solve for x here? Well, the opposite of dividing by 19 is to multiply both sides by 19. So I'm going to have x equals 19 times the sine of 40. I always like to find my trig function, my trig value first, then multiply by the whole number. So I'm going to go sine of 40, 19 times 0.64. But I would just leave whatever's in the calculator, multiply it by 19. X is 12.21. So this value here is 12.21. Okay. Let's go down here. Call this y. How could I solve for y? You have a couple choices. Let's pretend we don't know trig. What would we do? Pythagorean theorem, correct? So I'd have 12.21 squared plus y squared is 19 squared. 12.21 times 12.21, 149.08 plus y squared is 361. 361 minus 149.08 is 211.92. Let's take the radical of that. Y is 14.56. Well, let's double check that. It should then also work with trig. So let's find trig. Y in relation to 40. Y into relation to 40 is the adjacent, and that's still the hypotenuse. What trig function is adjacent and hypotenuse? Cosine, correct. So the cosine of 40 would equal y over 19. Multiply both sides by 19. Let's see what happens. The cosine of 40, 0.766 times 19, y equals 14.56. Same answer. All right? It's nothing in math was ever created. It was all discovered. It's all facts. So no matter how you solve it, as long as you're following the math rules, you're going to get the right answer. Okay? Let's look at the next one, maybe a little bit more challenging. I could throw you off sometimes. Let's call this 51 degrees. And let's say this is 8, and that's x. Okay? Hopefully you can see that. Let's zoom in, not on my missing hairline, but on the problem. Okay. So let's think. In relation to 51, this is opposite. In relation to 51, this is adjacent. Which trig function is opposite and adjacent? Tangent. So the tangent of 51 is 8 over x. We can't just multiply by 8. We can't just divide by 8. You may want to think about this almost like a proportion. Or you can just multiply by x and divide. We have to get x alone, right? We have to get x alone, and x has to be in the numerator. We're not solving for it from the denominator. So we can either think of it as cross multiplying, or I'm just going to multiply both sides by x. So I have x times the tangent of 51 is 8. What is the opposite of multiplying by the tangent of 51? Because remember, the tangent of 51, there's an actual value for it, right? There is a number value. So you could treat that like a constant. We're not going to figure it out right now. Wait till the very end, but it's like a constant. So what's the opposite of multiplying by the tangent of 51? Dividing. So I'm going to divide both sides by the tangent of 51. I'm going to divide both sides by tangent of 51. X equals 8 divided by the tangent of 51, 6.48. Is that a reasonable number? Well, let's see. If that's 51, this would be 39. That angle is smaller than that angle, that side smaller than that side. So it's a reasonable answer, and that is our answer. 6.48. Okay. There are some problems in your packets to try. Okay. We are just setting up each time, right? Finding what is the trig function in relation to what we have. Try some of the problems in your packet. The next video is going to be doing the inverse when we're solving for the actual angle.